Play Cape Talk.
Join the conversation the smart way.
This is Cape Talk.
It is 20 to 10, and what a lovely breather. It's always good having the Naked Scientist on to deal with those everyday questions, and he answers it with a bit of a scientific twist. We love it. Chris, great to have you back. What does your life look like these days?
Do you know, my life is busier than ever, Kino, because being a virologist and being a virologist who talks in the media as well, I'm quite in demand. And it's really interesting because on the one hand, you've got people who are stuck at home and they're really itching to do something, especially people who are big-brained scientists and, you know, big thinkers. And people are getting in touch with me going, I'm going stir crazy, stuck at home. How can I help? And I'm also doing a sort of sideline and connecting people up to interesting projects and other interesting things they could be doing to A, ease their tedium and boredom and tension, and B, help the whole effort. But at the same time, I'm getting enormous numbers of phone calls from people saying, can I explain more about what's going on? So there is a general dose of COVID dose, I think, going on around the world. So if anyone has any science questions that are not to do with coronaviruses, we'd welcome those as well. I think it's fair to say, isn't it?
I'll take those first, as a matter of fact.
Surely.
Because if I have to do 5 minutes without saying COVID-19, I'd be very happy.
That would be a welcome respite, wouldn't it?
So maybe what we should start with, and it's not coronavirus related, does regular hand soap kill? Oh, no, it is. I'm going to skip that one. It's amazing how things just intertwine. I'll come back to that one a bit later. Here we go. How did the birds survive the dinosaur mass extinction?
Well, we know they did because, of course, birds are direct dinosaur descendants. And just a couple of weeks ago, researchers at the University of Cambridge found the most extraordinary fossil. And like all these things, they've been sitting on this for 20 years. Someone had spotted this stone and they knew it had something interesting in it because there was a little bit of fossil visible on the surface. So they thought, that looks interesting, I'll put that in a drawer. And it didn't get looked at for 20 years. And then someone, I don't know exactly what the grounds were for doing this, CT scanned it. And they were absolutely in awe to see this incredible skull emerge. And inside this rock was the complete skeleton of a bird. Now, it's got it would have had a face a bit like a duck's face, so it had quite a long bill on it, didn't have teeth, so this was well along the lineage towards being a bird. But it clearly was dating from a time, because you can do various dating measures on the stone. You can date this to around about the last million years that the dinosaurs would have existed. So we know that by the time the dinosaurs were coming to the end of their reign and they were about to be pushed off their perch by the arrival of the enormous impactor that hit near Mexico and changed the world's climate forever and probably finally overturned the reign of the dinosaurs. This creature was already well established by then. The fact that we found such a good specimen of it argues these were probably not rare. And in the same way that you could say, well, why did crocodiles, which are also cold-blooded reptiles, they are very similar in style of habitat, behaviour to dinosaurs, why did they survive? And the answer will come down to because they were probably better at adapting, probably able to outmaneuver the impact. I don't mean as in the physical impact, but the consequential ripples that would have affected the climate, it would have affected food sources, etc., which enabled them to leapfrog the aftermath and then establish as one of the dominant circulating species. Birds are warm-blooded. This small creature today, so this small creature would almost certainly have been warm-blooded then, so that probably helped them to be able to overcome some of the climate instability. They're able to be very mobile, so that being able to fly, they could quickly cross large amounts of ground to go from one food source to another. So even though food might have become scarce, they probably were able to find the food sources that were surviving. They probably were quite gregarious in what they could eat. We know birds today can make use of a whole raft of different food sources. And as I say, because they're warm-blooded, they're cushioned to a certain extent against temperature instabilities that might have caused problems for land-dwelling dinosaurs. Crocodiles being in water, similar. Water can buffer your temperature a bit and make you a little bit more resilient. So that's probably why, but we don't know for sure because, of course, no one was there. It was 66 million years ago.
This is true. Now, Alison in Simonstown, Dr. Chris Smith's listening to you at the moment, and you want to talk about your carpet moving sideways. I can't wait to hear this question.
Chris, I've got this runner in a room, and I've always got to keep moving it because it keeps wanting to move sideways and go up the wall.
I've got the same thing, Alison. I've got the same thing. It's a long runner in a hallway, and
Yes.
every time I come down the stairs, it's halfway up the wall. Now, I do have 2 children in the house as well who are lazy bones, and they'll run down the stairs and run off. So I think they've probably got something to do with it. But actually, I do have the same problem. I know exactly what you mean. And I think the reason this happens is because the net force being applied to the carpet in my household is people coming down the stairs or going up the stairs. So they're either landing on the carpet and they're applying a force sideways to it, or they're going up the stairs and pushing off from the carpet. So there's a net sort of force on the carpet pushing my carpet sideways. But is your one not having people walking on it?
Not very much.
Not
And
very much.
I've turned it round, but it does go the same way.
Yeah, the way that they organise the bottoms of those carpets to stop them ruckling and rippling and becoming a trip hazard is they tend to put things that are quite stiff, but are also supposed to bed into the underlying floor, so that they don't move so much or slide around. And so that friction means that sometimes, depending upon what the pile is on your carpet, because if your pile runs in a certain direction, it may well be that there's more friction in one direction than another, because the runner finds it easier to move in one direction than another, because it's when it does have a force applied to it, that force is in one direction preferentially, or that the floor slopes a little tiny bit, or the pile encourages it to, whenever it's allowed to move, it generally moves better in one direction than the other. So you'll find it does migrate. The other thing to bear in mind, I've got another rug. It sounds like I'm like a Turkish rug factory or something. I'm not. I've got a rug in front of a log burner, and in wintertime this moves across the floor, and it's because of thermal expansion. It changes. I think because it's got it's a fairly cheap rug. You wouldn't put an expensive one in front of a log burner, would you? So it's got the material bit on the top and then this rubbery bit underneath. And I think the difference in thermal behaviour between the two causes the rug to move or change shape asymmetrically, and this applies a force, so it moves across the floor when you light the fire. And so it could be that in your case that there's a thermal effect as well, maybe aircon or the way that the air blows through the room might be making perhaps a small amount of heating effect differentially or cooling effect on your rug, and that also is changing its shape very subtly, and over time that translates into a movement. Fascinating that we've both got the same rug-related problem.
Now,
Thank you.
And I have to give you some advice here, Alison. I'm not a doctor, and I'm certainly not a scientist, and I know nothing about virology. But please, if your carpet keeps hugging your wall, please tell it social distancing is needed. Okay, thank you. Alison in Simonstown. Let's go to Alan in Tableview. Hi there, Alan. Good morning.
Oh, hi, good morning. Chris, I'm most interested in what enables a country to increase its money supply? What are the drivers that allows a country to do that?
I wish I knew, because we
That's
we
not
tried
a scientific question.
Well, no, I mean, it's quite funny. We were playing Monopoly at Christmas time, and someone decided for a joke to introduce quantitative easing, which is where the bank just prints money and shoves it into the economy. And we found that everyone got stupidly rich, but then no one could do anything because the money didn't really add up to anything. But no, we tried that with our own economy a few years ago, just printed loads of money and injected it into circulation. All it does is devalue your currency, which has been a problem for both of our countries in recent years. The answer is that where does money come from? Well, money comes from wealth in the country. Where does wealth in the country come from? Well, actually, I think the root answer to this is education. And I'm thinking big picture here, because at the bottom of the tree, you have educated people, and educated people go on to become very productive people who invent things. And when you invent something and you have an engineer or a scientist or a technologist who invent something, then that something gets turned into a patent, which then gets turned into a marketable technology, which the world wants. And then there's money collected from across the world flowing into the source country. And so I think, therefore, it just goes to show how important education and good teaching is to get the whole process started, because if you don't have an educated population, then you don't have the root to support that tree. So I think education's where it all begins, and that's how you make your country rich. You educate everybody.
Yeah,
So it's a long process. It's not something that we could do. How do we in South Africa increase our money supply?
Yeah, it's a generational thing. And people often say, what's the best thing you can do for a poor country? Do we give it food, machines? I think the best thing we can do for any country, whether you're talking top or bottom of Africa, Far East, wherever, I think the best thing we can do is we spend as much as we possibly can giving everyone the best education right now that we can, because education translates into so many benefits, especially for young girls, because at the moment there tends to be, in a lot of countries, you tend to find that the girls are getting undereducated, and this has this knock-on effect through families, so helping them is a priority. But if you intervene early, you give people the best chance to make the best of themselves, and we really have one go in life to get a good education. And that, I think, is money so well spent.
Well, I think that's good advice. Chris, thank you for that. Let's go to Colin. Colin in Bottersig. Hi there, Colin. Good morning.
Hi, Kino. Hi, Doc. Man, on a lighter note, in this stressful world that we're living in at the moment, headaches.
Yes.
Doc, a previous time, he covered this point about headaches. But, with my 2 standard 4s, I've also worked out that headaches comes very quickly when a husband gets amorous with his wife, especially in his lockdown period.
No. Do you know, I know somebody, right, Colin, who tapped his wife on the shoulder, and she said, "What?" And he said, "Have this." And he gave her an aspirin, and she said, "What's that for?" He said, "It's for your headache." And she says, "I haven't got a headache." And he said, "Brilliant, let's have sex."
A couple of people are going to try that at home. Colin, some great advice there, sir.
Thank you, sir.
Go and buy aspirin, okay?
Okay.
We have to have a couple of laughs, man. COVID-19 is nothing to laugh about, so let's talk about all the other things on the periphery, important things that we also want to get answers to, and that's why we've got Dr. Chris Smith, the naked scientist, and he can give you the scientific explanation to many of those everyday things you've always wondered about, right? So maybe right now you're sitting, and it's the first time you're probably listening to him, because every time we've done this show, you've been at work because you get to work at 7 o'clock. Well, now's your time to be part of the action as well. Now, if we slice Earth in half, what would it look like from space?
An Earth or a planet cut in half, I would think. But I guess that's not what you're asking. I think you're asking what is the interior anatomy of our planet. Well, put simply, it's a ball. And it's a roughly a ball. It's slightly fat around the middle, but then most of us. And it has a series of layers going from the outside going in. And those layers separate the crust. There's a big, thick crust material around the outside. And then there's a really thick layer called the mantle. And unlike the crust, which is hard, the mantle is squidgy. And I'm not using proper geological terms here. I'm making this as accessible for me and everyone else as I can. Then there is a core. Now, the core has an outer core and an inner core. And the outer core is the harder bit, and the inner core is the runny bit. And the core is made of the densest materials that are in our planet, and that means chiefly iron. So we've got a temperature down there of something like near 6,000 degrees C. It's about 5,700, I think, Kelvin. And this is obviously much hotter than the molten point of iron, which is why we've got molten iron around there. And we think the core is in motion, and the spinning iron core is what gives our planet its magnetic field. So if you were to cut the planet in half and look from the outside, you would see a solid, crusty bit on the outside, a hotter, squidgier mantle, which is very thick, and then you get down to the core, and the core has got a mixture of solid iron and then runny iron in the centre, and the distance from the very centre to the surface would be about 6,000 kilometres.
Okay, now we already have apologies being made, but it was bound to happen, Chris. Apologies for something COVID-related. But what is the naked scientist, that's you, thoughts on 5G and the conspiracy theories around COVID-19?
I don't have any thoughts on 5G other than this is a new technology which is going to give us more transmission bandwidth. And at the moment, we have no evidence that this is in any way harmful to health, but we are doing a giant experiment to find out. So, watch this space. But as far as we are aware, the radiation that's used in 5G, the microwave radiation, is not harmful to health. That's as far as we have in terms of data. Conspiracy theories around COVID-19 don't just revolve around 5G. People have suggested that perhaps this was a virus cooked up in a laboratory. People have been looking at this, and we've actually had the genetic code of the virus for quite some time. And actually, the structure that's there is very, very akin with what you would see made in nature. And as far as we can tell, this is not something someone cooked up in a laboratory. It is something that produced itself by the fact that there was probably a group of bats very close to some pangolins in a wet market in China, and they traded viruses, and bits of the genetics of one virus got mixed up with the genetics of another virus, made a hybrid, and it jumped into people who were in the market, and those people then began to transmit it. It doesn't look like that's something that someone did in a lab, because we expect that kind of thing, or we know this kind of genetic mix and match happens a lot in nature, and there are lots and lots of mistakes being made by nature. Most of them are a dead end, but the odd one works really well, and so the one you're going to see is the one time it does work really well and gets into people and spreads really well, and that's what we're seeing here.
Okay, Pam in Cork Bay, good morning.
Don't know very much about viruses, but do you have any very old fossil records of viruses? With us, with the first living sort of proper biological organism, not viruses, also have had viruses on them as soon as they developed.
Oh, hi, Pam.
You're talking about yeah.
Fascinating question. So it's sort of what you're hinting at is, well, where did viruses come from in the first place? And given that life seems to have them universally, well, how did they pop up? And as far as we can tell, the life on Earth goes back about 4 to 4.1 billion years. There is evidence of this from materials trapped inside what are called zircon. So you can go and find these tiny rock crystal fragments, and they have inclusions in them. They're almost like a time capsule. When they were forming, they captured some particles that were around at the time, and if you analyse the composition of those particles, you can see that they have made a specific choice as to what flavours of different chemicals. These are called isotopes, and life tends to use a different cocktail of chemical isotopes than non-living processes. And you can see the evidence, this fingerprint of life in the isotopes written into these samples from 4.1 billion years ago. So we know life got started then, and that first life was very basic chemical reactions initially that then turned into cells, probably some kind of cyanobacteria. These are blue-green algae-type bacteria that use energy from the sun to drive their chemistry. And we know they existed because we can find the remains of them today in the form of things like stromatolites. There are lots of stromatolites around Johannesburg you can find as well, big old-fashioned fossilised ones. So we know life got started pretty early. We also know that viruses probably got started pretty early as well, because if you look at the genetic sequences of viruses, they are very similar to the genetic sequences that we find at various processes in our own cells. So one theory of how viruses got started is that some of the functions that our own cells or our ancestors' cells developed in order to do various things unfortunately blebbed off, and those genetic elements got a life of their own and created or spawned this independent replicating cycle of life. So we think that viruses probably got started way back when life got started, because they were an opportunity for a selfish piece of genetic information to just exploit the processes that were causing life. So I would say that viruses are probably as old as life itself, or came along very, very fast after life got started. The genetic evidence for that is, if you look at the genetic sequences of some of the viruses we have around, you can find that they cross all the different kingdoms of life. And that suggests that they must have their ancestor way back when life first started to have elements from things that have gone into plants and animals and everything else. So this suggests that viruses are very ancient alongside our ancient ancestors. So I'd say they got started right back at the very beginning.
Well, thank you very much for that. We also have a voice note from Corin. Well, it's going to have to be a quick answer because we have a minute.
Please ask the Naked Scientist if the lockdown has... Is there any foreseeable increase in the population? Has anybody started doing that statistic yet? Because, with condoms not being available, and the fear of people dying, I foresee that there's going to be a lot of babies born 9 months from now.
It's an interesting question. It also depends on how long you've been married. But okay, Chris?
It also depends on how long you're locked down, because we've only been locked down for a little while so far. But the other thing that's happened, people have said there's going to be a surge in divorces, and there's also potentially, the figures I've seen suggest there's a big surge in people ordering more sex toys online as well. So obviously they're looking for diversions away from just making babies, but they're certainly having fun by the sound of it, unless they're arguing with their partner and getting a divorce, but that will come as well. This is going to be a very interesting sociological experiment, with some good parts and some less good parts.
Well, Chris, thank you very much for that. Always a pleasure chatting to you. You must have a wonderful weekend. That is Dr. Chris Smith back next week, same time, same place.